So hello everyone, welcome to the weather briefing. It's the 31st January of this year 2019. It is the first weather briefing of the year. I'm your presenter, Marko from Croatia, Croatian National Service, and I will try to tell you a few words today about the current weather situation and maybe a few things more. Okay, so let's start. Please just now tell me where you come from. You can mark with either a pointer or you can take some kind of shape, tick a cross or something and just put on the map. If you're from somewhere else than Europe or these surrounding countries, please write it in the other section. I'll wait for a moment or two now. It seems most of you have put your marks here. If somebody else is missing, I think it will not be a big problem. But anyway, thank you all for marking. Thank you. I'll just continue on. And the one first standard question, please highlight the jet streams on this water vapor 6.2 micro channel of today morning. I see a lot of you know what you're doing. I see some actually interesting answers that I will comment later. Yes, one very interesting actually. This is a good, somebody has a very good eye for this. Okay, thank you for the answers. I'll just clear this. Okay, so to see the solution, I have overlaid the isotext over this water vapor image. As you can see, most of you have got the jet streams right, so we have one quite strong here, accompanied with this cyclone. So this was the correct answer, and one strong here in front of the warm front of the same cyclone. Somebody pointed to this. This is also fine. This is a jet stream just south of here. It's not that visible and it's not that important for us, but it's correct. This is a very weak one. That somebody who pointed it had a very good eye, or maybe knew what's going on. And for this, I see many of you have actually put marking here. But as you see, there is nothing basically here. No wind. I mean, of course, there is wind, but not that strong, like for instance here. And I would explain this, that this is a deformation zone. Basically, deformation zone means that the wind here at this point is going like this. And in the water vapor 6.2 channel, and then consequentially in the air mass RGB, you can see this line as really dark, or in air mass RGB as reddish or brownish, in brownish color. So yeah, in the end, good exercise. Thank you for the answers. All of that is of course better visible in the air mass RGB. As you probably all know, in the air mass RGB, the jet streams are depicted in red or brownish colors. For instance, this one just behind the cold front, this jet stream just in front of the warm front, but it's rather poorly visible. The one that somebody noted here is basically not visible, but yeah, it is there. As you can see, the deformation zone here, it is brownish or maybe reddish for someone. And yes, of course, this one. And now I have actually two questions for you. What do you think is this? And if you pay attention, please look at this area and this area. You have some specific colors here in the air mass RGB, and what do these colors mean? Can you please answer me for the first area? You can write in the chat box, or yeah, you can. That's the best way. Does anyone have an idea? We'll see actually if I have a correct idea later on. I see no answers at the moment, no hands raised, so maybe you are not sure what that is, but it's not that big a problem. Let's just jump over this first part. Can you please tell me what this number 2 represents? So this area in Sweden, northern Sweden, and this area beneath the clouds in central Sweden. Let me just give you a hint, at least for the second area with this 24-hour microphysics image. You can see that the area here is very, very red. And in air mass RGB, very green. Actually, a tone of green. What could that mean? I'll give you 10 seconds if somebody answers okay. If not, we will continue. I have an answer from Cornell. Snow, yes, that is correct, but one more detail maybe is missing together with snow. But okay, yes, exactly. Cornell answered correctly. It is a very cold spot. So basically in air mass RGB, here you can see these very cold spots, very cold land and very cold air near the land in green contours. It's not the same as this green. It's completely different. But you can find these colors, for instance, in Siberia and in Canada and during winter, of course. So the explanation for the first area, I actually am not sure as myself if that is correct. Basically, this is a very dry patch of air at around 500 HPA. I've looked for PV anomalies. There is no PV anomaly. I've watched for jet streams. As you have seen as well, there are no jet streams there. And then I just looked at the relative humidity, a vertical cross section here, and it's only a very, very dry patch of air at around 550 HPA, which means that in the air mass RGB, the brightness temperature difference between 6.2 and 7.3 is big, because 7.3 gets its signal from 550 or 500 HPA. And basically that's it. If somebody else has another idea, we can discuss it later. And for the northern Sweden and central Sweden green patches on the surface, you can see the answer is here. This morning, the Swedes woke up to really chilly temperatures. It was down to -36 at some places, and usually something around -30 in northern Sweden, and actually even in central Sweden. So, as the explanation was before I gave, sometimes in air mass RGB, if the skies are clear, you can see very cold land in greenish tones, especially during winter, of course. Okay, so to overlay this air mass RGB with some ISO lines, so this is geopotential height at 500 HPA, we can see a very deep trough. Sorry, this is not so good line, but okay. And at the back of the trough, we can see a rather deep cyclone that developed over the last few days coming from Iceland. What else is going on here? Of course, this cyclone, as we mentioned before, we have some weakened cyclone, actually occluded front only from the analysis of Deutsche Wetterdienst, that is bringing some precipitation down here to southeastern Europe. And yes, to the east over Russia we have a high pressure system, and to the west we have a, let's say, a weak or medium strength ridge. When we're talking about precipitation, let's look what's going on in this big ridge that's occupying Europe. So this is a combination of 24-hour micro physics, opera radar, Europe, and observations. We can see that a lot of precipitation is coming from this cyclone, from its warm front, mainly here in Ireland, something over Iberia. And although there are no radars here, as much as I understand and I know, there is some precipitation that can be seen in the synop. Unfortunately, it is too small here, I believe, but there were some heavy rains or light rains or whatever from this weakened occluded front. To the north, we don't have that much. Actually, we don't have that much high clouds. As you can see, a lot of medium clouds, but we have snow, some rains, again some snow, also from the low clouds here, Poland, and from some high clouds there in Russia. We have some dense snow falling. So basically, it's quite active all around Europe. The trough is bringing very different types of precipitation and actually weather to whole Europe. For instance, here in Germany we have well, clear skies, and in Britain. Let's see the infrared 10.8 image with overlaid mean sea level pressure. We can see the lows all around Europe. Of course, this one is the most prominent. It was down to 972 hectopascals this morning. And now I would just like to ask you to mark the areas where you expect strong and very strong winds on this picture. This is actually a quite easy question when you have all these mean sea level pressure gradients. Well, we have some quite big area of very strong winds. Yes, but generally you get the idea. You're still missing maybe one area where there were at that moment some strong winds, some strong southwesterly winds. Yes, that was one. The yellow one and the dark red one were exactly that. Okay, let me give you a moment more. Okay, I think we've had enough. Thank you for your answers. Let's just shift to the solution, let's say. So these are the model winds. As you can see all around the cyclone, basically there are very strong up to gale force winds. At the tip of the occlusion front, the model gave around 35 meters per second winds. Unfortunately, or fortunately, however you look at it, there is nobody there because it's in the middle of the ocean. Unfortunately, because we don't have the exact numbers, but yeah, I believe it is something like that. So strong winds here down in Greece, southwesterly winds in the Western Mediterranean and to the west of Norway. And this actually really nicely follows the contours of our trough. Okay. Another question for you. Can you please mark the fronts of this, well, rather big cyclone? It's of course not all that inside of the area I encircled, but I don't want to give it away. Okay, we have some fronts here and there. And as you can assume, I will proceed into analyzing in short notes this cyclone. Okay. I think you got the idea where it's actually located and where are the fronts here. So I would thank you for your contributions. Let's just move to the other slide. Now I'll just show you in the second and in the following slides the three vertical cross sections I pulled myself this morning. So basically warm front, occlusion, and cold front. Okay, let's start with the warm front. So as you've seen, I've pulled a vertical cross section here, and the front can be really nicely seen in the VCS. It is inclined as it should be. We have some moisture going over the front, being pulled by this upward motion of the air. And as we can see, there is a rather strong warm advection in that area, actually on the surface of the front. To continue, we go to the occlusion front. I'll just say a few words. Nothing special here. We have a really nice textbook V shape in the isotopes. You can see it, of course, here, and most of the humidity of the occlusion, of course, is trapped between the, let's say, the cold front part of the occlusion and the warm front part of the occlusion. And some omega the omega is the strongest at this, let's say, cold front part of the occlusion, where we have actually that precipitation over island that you saw just minutes ago. To continue to the last ingredient of this cyclone, to the last part, actually to the cold front, we have the nice, again, inclination of the isotopes, some but not a lot moisture, very strong cold advection over the frontal surface, and actually very little omega in that part. But what is interesting is there are no clouds. Can somebody tell me what's going on here? So we have a quite clearly a cold front, really very nicely visible in the isotopes, in the cold advection, but where are the clouds? You can write again in the chat box. You can write on the image if you like. I'll just wait a few moments more because I've put a bit too much of stuff in this presentation. Cornell said one very good answer. That is actually, yes, one of the ingredients. Yes, the left entrance. You meant the yes, actually, and the left entrance, and actually here we have the right exit of the jet, the downward motion. So basically, and one of the reasons, again, is the very strong cold advection there. That is basically destroying the cloudiness. If we shift to the air mass, again with the isotext, we can see the jet core here. And as actually Cornell said, and later Renato, we have here the right exit of the jet, and we have here a negative vorticity advection, which is then destroying the cloudiness, which leads to the conceptual model of frontal decay. But actually, yes, this image was taken at 6 UTC, and just a few hours actually later, the front began to regrow back. That you can actually see it in your satellite images. Okay, let's now shift just shortly to across the pond. As you probably all know what's going on there, it's quite cold. As you can see on this 10.3 micro from the GO-16 satellite, you can see a really nice wave here, really bright wave. That means in 10.3 that the air is really cold there. It's comparable to some clouds around the area. And if we switch to the upper level, actually to the geopotential height at 500 HPA, we can see a very deep trough again, similar to Europe, but again, not at all. At the ground, we can see a low, but as well, we can see a high. So actually, we have high gradients between the two systems, and basically that creates a strong wind that is actually further pushing the very cold air down into the States. How does it look like on the air mass RGB? You can see very dry and very cold. This is also what I was talking to you, the greenish colors, very cold, and the reddish colors very dry, as you can see here. Again, the bluish color is for the humidity in the upper troposphere, yes. The red is for the mid-troposphere, and the green is for the temperature. And as you've probably heard from the news, it is quite cold. You can see Chicago -30, some places near the border -37, Canada up down to -45 in some places. It's quite frigid. But yes, that happens sometimes in a few years, once or maybe, yeah. And here actually as well for the end, I would just like to point out that there is a nice case of lake snow, actually snow effect, lake effect, sorry, lake effect snow going on over Lake Michigan, Huron, and the others. And just one image from frozen Chicago and frozen beach on Lake Michigan. And that would be it from me. We can hear you.
Marko, can you hear me?
Yes, yes.
Hello, everybody. Welcome. Welcome to the second part of this session. My name is Yasmin Markl. I am working for the Austrian National Weather Service, ZAMG. My office is in Salzburg, middle of Austria. And I would like to show you now a weather situation that we had recently here in Austria, a very intense snowfall in the beginning of January. So I would like to start with another picture of myself while skiing next to a house that is almost completely snowed in. This is just a couple of days ago. This was last Sunday, and yeah, so it was much fun, but I also want to emphasize that such amounts of snow are not always much fun and can cause troubles and danger, actually. I would like to speak now a bit about the weather situation and about the dangerous risks and everything that we had to deal with. So first, let's have a look at the larger scale synoptic situation. This is an animation of geopotential for the first half of January. I will play it now for you, and you can see, especially if you look at Austria, that almost persistently, or with some breaks, but still almost persistently, we had this northerly flow or flow from northwest that brought also different frontal systems to the northern side of the Alps and heavy precipitation. So from 4th of January till 15th, there were 3 major phases that caused lots of snow, meters of snow actually, and yeah, mainly at the Northern Alps. And for you to get an impression where the Northern Alps are, here's a map of Austria. Maybe just get the pointer. So different parts of the Alps, so to speak. Here we have the Northern Alps. This is this area, and for example, the Central Alps just next in the south. Here I have marked the 3 phases where we had the major precipitation. First from 4th till 6th of January, then from 8th till 10th, and from 13th till 15th. So yeah, the 3 phases to show you about the weather. We have issued a red warning for snow, of course, most of the time for snow. The first phase was for intense snowfall reaching till the main alpine ridge, so a bit more to the south. Second phase, pure northerly flow. And the third phase was intense snowfall again, and also then rain because it got a bit warmer, down to 1,400 meters. So overall, lots of precipitation, and for a very long time, a constant or almost constant red warning issue, which is the highest level of our warning. So this is something very unusual. So, okay, this is a chart from 10 10th of January. So the third phase has not begun yet, but only the second two phases have already brought lots of snow. This is from Schmittenhöhe. This is a station, one of our stations here in Salzburg. And by the end of phase 3, there were 3 meters of snow, settled snow. So it's not only the sum of the fresh snow, it is really settled snow. So including melting and all processes. Okay. Yeah, of course, also the danger of avalanches was rising a lot, and for a couple of days we had warning, warning level 4, and sometimes also in some parts level 5, which is very high risk for avalanches, and that is something that occurs probably like every 10 years, so it's nothing very usual. And at level 5, you don't go to the mountain at all, and maybe you even cannot really step outside of your house, or at least outside of your, let's say, village. This was the warning for avalanches. I will not go through it now, but yeah, you can read that there was very high avalanche danger, and it's very important to get this information if you would like to go on mountains or doing sports. Yeah. Okay. And some measurements to get a feeling. So at some stations we have measured a record since quite a long time. For example, well, this goes from 1.50 meter of meters. This now is the sum of fresh snow, so this is not what's lying there now, but this is like if you sum every day up, then you get to this number. So you have to make a difference between the snow that is lying there at the moment and the snow that the sum of the fresh snow. You also can see that such events occur like, yeah, around every 100 years. So this is something that could be once in our lifetimes. All right, some damages. Unfortunately, there were many damages, of course. So there were 15 people dead in Austria, mainly due to the avalanches. Yeah, many roads were blocked, also railways. Many villages and persons were isolated for a couple of days, and the highest counting for people that were isolated in their villages was on 15th of January with over 86,000 people that were locked in. Temporary power blackouts in some regions. Schools and kindergartens were closed for a couple of days. Of course, problems with snow, that is snow weight on trees, so breaking trees, and then especially the combination of snow, then rain, and then storm that broke many, many trees. Yes, and also, of course, the loads on buildings and roofs. Some of the lighter roofs even broke. And yes, the avalanche risk that was very high, especially in Northern Alps and in the Central Alps. All right, so let's look at some images here to get a better impression. Roadblocks, breaking trees. Yeah, you can imagine here the railway is snowed in. Then we have got, yeah, some breaking roofs, especially lighter roofs, glass houses. Many, many roofs had to be removed from snow to minimize the risk of breaking. And yes, avalanches, of course. So many people already in January this year died in avalanches, and there is lots of snow still left up at the mountains. So please everybody be careful if you make holidays in Austria and yeah, go to the mountain. There was a hotel that was damaged by an avalanche, luckily during the night, so nobody was hurt here. And here I have a video I would like to show you. This is a powder cloud avalanche in Tyrol, and there is unusually much snow, so the avalanches have more power than usually, you could say, and also they reach farther because there is, okay, right. So yeah, this is already the end of my part. Thanks for listening. And the next weather briefing will be on February 27th, held by the Portuguese Institute, IPMA. And for my part, I would like to say goodbye with this small video.